In this video, we're going to apply an integration by parts formula again to more examples. We're also going to start talking about how to select the u and dv part. We're given an integral and we need to identify each part of the integral with those two components. And there are some definite strategies for doing that. That being said though, it's important to recognize that you need to experiment. There is nothing that you can break by doing this, and all you have to risk is about 2 lines of calculation before you realize that something's not working. So if you're intellectually honest with yourself when you go through these processes and recognize when you've made an error or something that's not helping, take a step back, try a different u and a different dv. That is actually the most effective way to get some insight into what works and what doesn't work. With that being said though, there are some guidelines that can be helpful. The first guideline is that you pick your u so that when you differentiate it, which is the next step, that derivative is actually simpler than what you started with. That's usually easy to arrange. The second one tends to be a more important one. The dv part, you're going to have to integrate that. So ideally that integral should be simpler than what you started with. And actually the bigger barrier is you might have chosen a dv that can't be integrated either easily or at all. And so that would point to a problem with that u-dv split. If you can't actually integrate dv, go back and pick something that you can integrate before you go any further. So this combination and the idea that the derivative of u should be simpler, that gets you through most of the examples in integration by parts. Everything else, there's not a lot of options in these things, so a quick experiment with a couple of u and dv choices will usually lead you to the correct approach that'll give you a simpler integral. Let's see this through a few examples. Consider the integral of x cos of x with respect to x. Based on those guidelines, what do you think a good choice, again, for a starting point, knowing you might have to go back, what would be a good choice for u and dv? Think about that for a moment, pause the video, and then we'll check in. Okay, so remember that we're going to differentiate the u part to get the du, and the dv we are going to integrate to get the integral of the dv part. So there's 2 natural processes here. Somebody can rule out of the gate. This one here, we're going to be integrating x cos x. Well, we don't know what the integral of that is. If you think about that for a moment, it's not an obvious integral. So it doesn't make any sense to have to integrate that as part of our process. We're trying to simplify that in the first place. This case here is reasonable. And notice we can pick something as simple as dv to be dx. That's totally allowed, as long as there's something in there and the dv has to keep the dx part. The problem with this, at least at first glance, is that your derivative of x cos x is going to be a product rule. So you're going to get a complicated du on that one. So I wouldn't rule this one out, but it would be lower on the priority scale. Something we would try last. So that leaves us with a 2 here. If we have dv equals cos, we can certainly integrate cos, no problem. And if I differentiate x, I get 1. In the other case here, if I put the cos in for u, when I differentiate cos, I'm going to get negative sign. And I can certainly integrate this, but it's going to turn into an x squared over 2. This little side calculation says we're probably not going to be better off with this. I want to simplify what I'm getting back. And here I'm getting my x, which is the problem. The fact that I have a product in here at all is what's complicating this integral. I'm turning that x to the power 1 into an x to the power 2. That's like more x's. So this again seems something that we would try later. This is nice. This is a simpler expression. And the integral of cos is just sine, so we don't complicate our lives with the integral side. We can do the integral and it's about the same, but the derivative of the u is definitely simpler. So this is the one that we would recommend as the next step. Please do notice you have to have your integral and your derivative rules for these simple functions down, and you have to be able to keep them clear in your minds when you're differentiating or integrating, because you will be literally doing the opposite operation side by side on the page when you're doing integration by parts. So if you're not comfortable with the derivative rules or the simple antiderivative rules, go back and practice that work from the previous units. It'll really help make this process work a lot more smoothly. All right, now let's tackle the evaluation of this integral with our choice of u being x and dv being the cos of x dx. Once you've made that choice of u and dv to split up every component of this integral, the integration by parts formula dictates everything that follows. What we've set up is going to be replaced by u times v minus the integral of v du. So let's go tackle that by filling in what v might be and what du might be. Take the derivative of the u part. We get 1, or more explicitly, we're going to have a dx equal to our du. On the other side, we're going to integrate, and I like to write it in here explicitly. The integral of implicitly a 1 here dv is going to give us v, and then the integral of cos is sine of x. Again, we skip the plus c because we'll be adding that in later on in the process. Notice the derivative of sine is cos. That's why it's not negative sine up here. Next, a little mnemonic with the arrows here. Our integral of x cos of x dx can be replaced by u times v, uv, so x times sine of x, minus the integral of v, sine of x, du, and du is just dx. Perfect. Let's put those notes in here so we can track where everything came from. Away we go. And then we ask ourselves whether we've created a simpler integral. Along the way, we also noted that we could integrate the dv part. There was no trouble there. So now the next step of evaluation is this a simpler integral? Absolutely. The integral of sine we know. We just copy the leading elements here. And what do I differentiate to get sine? This is where we get a negative cosine back. And plus c. And it's always nice to tidy things up if we can. We'll have an x sine of x plus cos of x plus c. Again, not at all obvious that this is the antiderivative of x cos x. I'm just going to copy here again. Again, given that this process is new, we should verify that our antiderivative is correct. We do that by writing out our integral, and then our check is that the derivative of that right-hand side gets us back to the x cos x. So we take the derivative of x sine of x plus cos of x plus c. What does that equal? Well, we have a product rule first, so we'll have derivative of the first times the second plus the first times the derivative of sine, which is cos, plus the derivative of cos by itself, which is negative sine, and plus c's derivative is 0. And what do we see right out of the gate? We have a positive sine of x, a negative sine of x that cancel, and so we are back to simply x cos of x. That matches our original integrand, and so we have the correct antiderivative.